Hi, grade 7 students. This is day 30, page 477, numbers 13 through 53, the odds. I hope you pay attention to this lesson because I am right now changing the assignment to 13 through 43, the odds. I'm making it a little bit shorter, so hopefully you paid attention to this video. It'll make your assignment go a little bit faster. Before we get started, please read through the examples carefully on 474, 475, and 476, and then join me and we'll take a look at some example problems on the board. Go ahead and pause it now. Okay, here we go. We're going to start with this problem right here. Today's lesson is about solving two-step problems. We want to remember one thing about this, that there's a left side to the equation and there's a right side to the equation. And the left and the right sides of these equations are always on the left and the right side of the equal sign. So when I talk about the left side of the equation or the right side, please make sure you understand that, okay? Let's take a look at our first problem. We've got a variable. We want to figure out what it is, but it's attached to this 6 by multiplication, and it's attached to the 5 by addition. I'm going to get rid of the 5 first. We always get rid of subtraction or addition before we get rid of multiplication or division when it comes to these style of problems. And you'll notice how I'm doing it. What is the opposite of adding 5? I'm going to subtract 5 from both sides of the equation. And when I do that, I get 24 on this side. And on this side, the adding of 5 and the subtracting of 5 cancel each other out, leaving me with 6x. Now, what do I do next? I got to get the x by itself. The x is attached to the 6 by multiplication. What's the opposite of multiplying by 6? Let's divide by 6. And we'll do that to both sides of the equation, and we get x equaling 4. 24 divided by 6 is 4. Okay? So that's our first answer. We got the x all by itself by first getting rid of the adding of 5 by subtracting 5. Then we got rid of the multiplying by 6 by dividing by 6. We're doing opposite operations here. Let's look at this next problem. 9 times m minus 11 equals negative 2. I'm going to get rid of the 11 first because it's attached by subtraction to the variable. So I'm going to add 11 to both sides. We have to know how to add a positive to a negative number together. Do you remember the 3-step rule? Think about their absolute values, subtract them, and then which one had the bigger absolute value is going to share its sign with the answer. Over here, we're left with 9m because adding and subtracting 11 cancel each other out. We divide both sides of the equation by 9. And we get an m value of 1 in this particular case. Let's move on to this one. Notice how most of the stuff is on the right side this side. But that's okay. We still want to get p all by itself down here. So we got to get rid of the 2 and the 13. Can you tell me which one we get rid of first? If you said the 13, you're right. We got to do the opposite of adding 13, which is subtracting 13. And we're going to do it to both sides. And that gives us negative 12 over here and a 2p here. How do I get rid of the 2? I do the opposite of multiplying by 2. I'm going to divide both sides by 2. And that gives me a p-value of negative 2. Opposite operations. We get rid of any addition or subtraction first, then we get rid of any multiplication or division next. Let's move over to this problem right here. Can you see it? I think you can. There we go. We got 10 equals a divided by 4 plus 3. What part of this are we going to get rid of first? We're going to get rid of the adding of 3 by subtracting 3 from both sides of the equation. The opposite of adding 3 is subtracting 3. We get 7 here, And we get a over 4 here because these concepts cancel each other out. How do we get rid of a divided by 4 so that a is by itself? We do the opposite of dividing by 4, which is multiplying by 4. And we do it to both sides of the equation. So a has to be 28. Let's look at this next problem. Right here. Are we going to get rid of the negative 2 first or the 4, the subtracting of 4 from the c? Well, always get rid of subtraction or adding first. So that tells me that we are going to do the opposite of subtracting 4, which is adding 4. And we're going to do it to both sides. And that gives me c divided by negative 2 equaling 7. How do we get rid of dividing? By multiply. So c over the top of, or divided by negative 2, times negative 2 equals 7 times negative 2. Notice we do it to both sides. We added 4 to both sides, and now we're multiplying both sides by negative 2, and we get a c value of negative 14. Okay, this next one's a little tricky, but not too bad. Do you notice how this problem is similar to, but slightly different than, say, this problem right here? Look at them carefully. Do you notice how up here we start with the coefficient attached to the variable minus 11, minus the constant. But here it's the constant minus the coefficient times the variable. When you see this kind of pattern, constant minus the coefficient times the variable, be careful. You got to handle this one a little bit differently. Your first step is changing the subtraction to adding a negative 5y. Now, we didn't change the value of this expression on the left side here by doing that. We're just changing it into a different form that makes it easier to solve. Okay? If I hadn't done that, I'd be tempted to add 3 to both sides, but that would not give me the right answer. I instead, look at this, notice how the 3 is being attached to this y by addition. I really need to subtract 3 from both sides of the equation to get that y by itself. Over here, I get negative 40. Over here, I get negative 5y. So, just to review that, if it's the coefficient times the variable minus the constant, you can just simply add 11 to both sides because that's the opposite of subtracting 11. But if it's the constant minus the coefficient times the variable, then you need to rewrite it first as adding a negative because this coefficient needs to be a negative value. And we actually, in this case, need to subtract 3 from both sides. Now, down here, we still got to finish this. How do we get y by itself yet? We're going to do the opposite of multiplying by negative 5, which is dividing by negative 5. And when we do that, we get a y value that's equal to 8. Negative 40 divided by negative 5 is positive 8. Let's take a look at this problem right here. It's off the screen, but there we go. This is another one of these that's similar to the last problem where we have the constant subtracting the coefficient times the variable. And if you see that, immediately change it to adding its negative value. Change subtraction to adding its negative value so that you don't get tempted to do the wrong thing. In this particular problem, our step at this point is to subtract 9 from both sides of the equation. When we do that, we get 10 on the right-hand side, and we get negative 5w on the left-hand side. So, because we start with a constant minus the coefficient times the variable, we've got to change that to 9 plus a negative 5w, because subtraction is the same thing as adding the opposite of that second number there. Now, how do we get rid of the negative 5? Get rid of the negative 5 by dividing by negative 5, and we do that to both sides, and we get a w value, because these negative 5's cancel each other out, equaling -2. We got that same issue in the next problem. Notice a constant minus a coefficient times a variable. So I'm going to rewrite this as 18 plus a -4w. Then, do I get rid of the -4 first or the 18 first? Well, I got to get rid of the 18 because it's attached by addition. So I say, okay, what's the opposite of adding 18? That's subtracting 18. And I do it to both sides of the equation. And I get a -4w equaling -16. Then I got to get rid of that -4. What's the opposite of multiplying by -4? Well, that would be dividing by -4, right? And that would give us a w of +4. A w of +4. Now, just if you don't trust me on this, let's take that 4 and put it back up here. What's 4 times 4? 16. What's 18 minus 16? That'd be a +2, right? Okay, let's move over here, look at some other problems. The problem on the top here looks rather simple, but be careful. This is really one of those problems where you have a constant minus a coefficient times a variable, because there is a number here. It is the number 1, right? This is really 4 minus 1 times d equals 11. So be careful. First thing I would do is rewrite it as subtracting a -1d. Then, let's get d by itself. Let's get rid of that 4. The opposite of adding 4 to a -1d is subtracting 4. That would give us 7 equaling a -1d. Then I need to divide both sides of the equation by -1, because I got to get rid of that -1 on this side. And when I do that, I get a d value of -7. Oh boy, I bet you're getting sick of these problems where it's the constant minus the coefficient times the variable. This one doesn't have that, does it? How do we solve this one? Well, this is just a standard problem. How do we get n by itself? We got to get rid of one of these two numbers. Which one do we get rid of first? We get rid of the 1 first. The opposite of adding 1 is subtracting 1. We do it to both sides of the equation. It gives us 6 equaling -2n. Then we got to get rid of the -2, so let's do the opposite of multiplying by -2, which is dividing by -2, right? And that gives us a -3 equaling our n value in this particular case. This one's interesting. It's a little bit different. Notice you've got 6k minus 10k equals 16. This is different because the first thing you have to do here is just combine these like terms. 6 minus 10k. 6k minus 10k is -4k. So this is a much different problem than most of them we faced so far. But no big deal. We just simplified the two terms that are being subtracted. And then, now let's get rid of the 4 by dividing by -4. Why am I dividing by -4? Because that's the opposite of multiplying the k by -4. And that gives me a k value of -4 when I do this divided by this. Let's come over here to this one. Pretty simple problem, actually. I got to get rid of the 2 and the 17, so that b is by itself. Which one do I get rid of first? Well, I got to get rid of the 17 first, right? So I'm going to subtract 17 from both sides of the equation. And that gives me 2b equaling -6. Then I need to divide both sides of the equation by 2 because I got to get b by itself again, right? And that gives me a b value of -3. Let's go to this one. Is this one where we have to think about being careful? No, it's not. Not really, because this is one where it's the coefficient times the variable minus the constant. It's not the constant minus the coefficient times the variable. So with this one, we can just simply jump right in to adding 5 to both sides of the equation. And that gives us this, 6 times p equals negative 12. And then we can just simply divide both sides of the equation by 6. And we get a p-value of negative 2. How about this next one? Again, coefficient times the variable minus the constant. So this one we can just jump right in. We don't have to worry about that weird format. We can just jump right in and add 9 to both sides. And we get 25 equaling 5x. So obviously, what does x have to be? Once I divide both sides by 5, I get an x value that's equal to 5. Believe it or not, that's supposed to be a 5. There we go. Okay, let's jump down here. Just a few more problems to go. With this one, how am I going to get d by itself? Well, let's subtract 13 from both sides, because that one needs to go first since it's attached to the d by addition, right? And that might be the tricky part here. This is negative 21 when you do the subtraction. And then divide both sides of the equation by 3, and you get a d value of negative 7 there. Okay? How about this next one? Is that tricky? Hopefully not. The y is attached to the 8 and the 5. Which one do we get rid of first? We get rid of the 5, because the 5 is attached by addition. So what do we get? We get y over 8 equaling, what's that? That's negative 8, right? Now we got to multiply both sides by 8 because y is attached to this number by division. So the opposite of dividing is multiplying. And we get a y value of negative 64. Does that show up on the screen? Hopefully, I think it does. And our last one looks a little weird because it's got a fraction in it. Oh no! Don't panic. What are we going to do first? Well, the 15 is attached by addition, so let's add. No, I'm sorry. Let's subtract 15 from both sides, right? Let's subtract 15 from both sides. And that gives us 13 over here equaling negative 1/4 w. What's the opposite of multiplying by negative 1/4? Well, dividing by negative 1/4, right? We should be able to do that. Divide by negative 1/4, and we got to do it to both sides of the equation. Do you remember the rule about division of fractions? It should be on that sheet in your math book. To divide fractions, we multiply by the reciprocal of the second number. I'll say that again. To divide fractions, we multiply by the reciprocal of the second number. So really, this becomes 13 over 1 times negative 4 over 1, which is negative 52 when you do all the simplify. So w in this case is a whopping negative 52. Okay, hopefully this helps you. If not, please give me a call, 517-242-3138. Thank you and have a great day.